This video is our last video for this unit for circles, and we're talking about the area of circles and certain portions of a circle, which is called a sector. So you're doing this on the reddish-orange color circle from earlier. So if you notice, this left-hand side is 11.4. And then this right-hand side is what you're filling in right now. So if you don't have both, you can fill out both of them right now. But otherwise, we're really just talking about this right-hand side. So the area of a circle is right here, so pi r squared. And remember, the r is a radius. The sector, if you are asked to find the area of a sector or just a certain portion of the circle, that's really what it is. So it's a certain pi piece of your circle, so it still starts at the center. So like the shaded part is its sector. And what you're doing is you're taking a certain percentage of the area. So if you remember how to take a percentage of something, you take the degree of our arc, or the degree of the central angle really, divided by 360, so that's the percentage part of it, and then we multiply it by the formula for the area. So it's the percentage times the area of our circle, so pi r squared. So down here, if I know that this is 210 degrees, I can subtract that from 360, that's right here, and I know that this shaded part then is 150 degrees, so that's my number I put in here because I want that section of my circle divided by 360, and then times my radius squared times my pi, so that's my 6, and then so pi r squared. So once I do that, first I reduced my fraction, and then I took 6 squared to get my 36, and then I'm multiplying all top numbers together. So 5 times 36, and then I divide it by the 12. So I get 15, and then once I multiply that by pi, I get 47.124. For these questions, we are going to find the area of the circle shown, and we need to use our formula for the area of a circle, which is our pi r squared. All right, so they give us the radius, so we can just plug it straight in. So our pi times r squared, so pi times, here is going to be 2.5 squared. So you can type that all in your calculator. If you don't remember where the pi symbol is, if you look on the right side of your calculator, and it is right underneath the clear button. So once we type that in, we get 19.63495, except we want to stop it after the thousandths. That's how we're going to round all of these. So we're going to do 19.63, and if you notice, this is a 9, so it's going to bump this up to a 5. And it is centimeters, so it'll be centimeters squared because we're finding the area of a circle. So for the next picture, we have our diameter is this. So notice we need to use the radius in our equation, so we need to divide it by 2. So when I divide it by 2, I get 56.55. So when I plug that in to my equation for the area, I get pi times 56.55 squared. Remember, type that all in your calculator at once, and I get 10,046.507, and that's exact. I don't have to round in this one, so I can immediately put my centimeters squared at the end. So the sector of a circle is a region bounded by 2 radii, so 2 radius segments, and their intercepted arc. And the intercepted arc would be my arc AB. So this is the same equation that I had written down on my circle, so it's taking a certain percentage of the area of my circle. So that's where this part comes from. Here's my percentage, and here's my area of a circle. So then I want to look for the red section. So if you look on the side, that's my red part right here. So I'm taking my degree first, so that would be my 70, divided by 360 always, so that's my percentage, times pi r squared, so pi times 8 squared. And what I usually am going to do first is I'm going to simplify this first, so I have 70 times pi times 64 all on top, all divided by 360. So if I combine the 70 and the 64 together, that will give me 4,480. I still have to multiply that by the pi and divide by 360, but that way I simplify as much as I can first. So when I type that in the calculator, I get 39.0953. We're stopping it right there, so I'm going to write 39.095, and this is, we don't have the units, so it's just going to be units squared. So if you don't have the units, still put some type of units down. All right, for the blue section, I need to put the degree again, so if you notice, we're not given the degree, but I can subtract off my 70 that we are given, and that gives us 290. So that's the degree of the section of my circle that's taken up by the blue. So 290 divided by 360 times my area of a circle, so times pi r squared. Again, I'm going to simplify the 8, so I get 64 on top now with my pi, my 290. I'm going to combine the top part together, so my 290 and my 64. I'm going to multiply those together, and I end up with 18560. And I still have to multiply by pi and then divide by 360. So when I do that, I get 161.96655, and I want to round it to the thousandths. So I need to stop it right there. So it'd be 161.967 because this 5 bumps that up. And this again does not have units, so we're just going to write units squared. This is just another one that I would like you to try on your own. So notice that this is the red portion, and this section over here is the blue portion. So remember, you're taking the degree divided by 360 times pi r squared, and then simplify it. So go ahead, push pause, and when you're ready to check your answers on both of them, then go ahead and push play. All right, so for this first one, for the red, we should have 120 over 360 times your pi r squared, so 14 squared. When you simplify that, you should get 120 times pi times 196 over your 360. When you combine the two numbers together, this is what we get, and then we have to divide that by 360, and you get 205.25072. So when you round that to the thousandths, we'll get 205.251. And this one does have units, so it'd just be feet squared. All right, for the blue section, the degree we need to find, so we need to subtract 120 from 360, and we get 240. So that's our degree we're using, divided by 360 times our pi r squared. Again, I need to simplify what I can, so 240 times pi times 196 over 360. Combine my two numbers together and multiply those, and I end up with 47040, and then still times pi over 360. When I type all that in my calculator, I get 410.50144. When I round it, it stays 501 since the 4 is not bigger, and then this is still feet squared. All right, for these very last two, I just gave some different types of problems you could see. So in this first one is with a clock, and the clock, we want it to be 7 o'clock. So you have to change the time. So you want it to be on the 12, and our hour hand then would be on hour 7. So we want this portion of our clock. So we need to find the degrees of that portion of the clock. So to do that, if you think back, we did a warm-up like this a while ago. So if we take 360 divided by the 12 sections on our clock, we get 30 degrees. But we have from 7 to 12, there are 5 sections in there. So we need to multiply by 5. So this portion of our clock is 150 degrees. And now we can go ahead and set everything up. So our degree over 360 times our pi r squared, which is our 5. Then when I multiply my 5 squared together, I get 25. And then remember, we're multiplying these two together. So 150 times our 25. And we get 3,750 times my pi still over 360. When I type that in the calculator, I get 32.72492. And then when I round it, I get 32.725, since that 9 bumps it up. And this is inches, so it would be inches squared for my final answer. All right, for this very last one, we are doing just the red portion. So we need to add up all of these 3 numbers together. And we find out that the red section will take up 187 degrees on our circle. So we're taking that number over the total degrees, so over 360, our pi times r squared, so 3 squared. And then if I simplify the 3 squared part of it, I get 9. I need to simplify my numbers on top, so 187 times 9 gives me 1683, and then I still have times pi divided by 360. So when I type that in the calculator, I get 14.686945. Remember, I'm using the pi button on my calculator. And this 9 bumps that next one up, so it will be 687. And this is inches, so it would be inches squared.